Alright, so we'll talk about non-permissible values now. So first of all, what is a non-permissible value? It's a value that when you put it into a rational expression, so you substitute it in for the variable, it makes the expression impossible to evaluate. And the most common case of a non-permissible value is a value that makes your denominator equal to 0. Here's an example to show what I mean. So if I have 2 over x, if you think about it for a second, if this x is equal to 0, then what I've got is 2 over 0. Of course, if I try dividing 2 by 0, well, I can't do that, right? It's undefined. It's impossible to evaluate. So that means that x equals 0 would be called a non-permissible value for this expression. Non-permissible means not allowed, so it's not allowed to be put in for this expression because it makes it impossible to evaluate. So let's look at a couple of examples of how you would find non-permissible values. So let's start with the first one here. So I've got 4x cubed over 4 minus x. So first of all, it doesn't matter what's in the numerator, because if you think about it for a second, if my numerator is equal to 0, say if I have 0 over 2, well, 0 divided by 2 is equal to 0. I can evaluate this, no problem. So it doesn't really matter if my numerator is equal to 0. Okay? So in that case, I don't need to be concerned with the 4x cubed at all. All I need to really worry about is the 4 minus x. So I know that it can't equal 0. So what I can do is I can just say, okay, I take whatever is on the bottom there, and I just write a little mini equation or inequality. So 4 minus x cannot equal 0. Okay? And I can solve this the same way that I would solve a typical equation. If I want to get the x all alone here, I could do it two ways. I could get rid of this 4 by subtracting 4 from both sides. So I would have to subtract 4 there and subtract 4 on the other side to keep it balanced. So that would then give me negative x cannot equal negative 4. Of course, then this is the same as negative 1 times x. So to get rid of the negative 1 now to solve for positive x, I would divide by negative 1 on both sides, because what you do to one side you have to do to the other, giving you x cannot equal positive 4. Okay? So in this case, x equals 4 is the non-permissible value for this, or you could write it like this, saying that x cannot equal 4. Okay? So writing this or this is fine. Okay? You'll commonly see it written like this. So x cannot equal 4. Second example here, so you realize that this is actually a quadratic. Okay? So you might have to delve a bit back into your quadratic knowledge. You'll actually notice that it, again, doesn't matter what my numerator is going to be. I'm only looking at the denominator, so I just take my denominator and I say, okay, it cannot equal 0. Again. Alright, well, how do I solve this for x? There are actually lots of ways. If you want, you could say that this is plus 0 right here. So you have an a value of 1, a b value of negative 5, and a c value of 0. And then use your quadratic formula. So x equals negative b plus or minus the square root of b squared minus 4ac over 2a. That would work. Be a bit time consuming, but it would work. Okay? Or, in this case, since these two things have common factors, this has an x and that has an x, so I could factor out my common factor. Okay, this will be a bit quicker than using the quadratic formula. So if I factor out my common factor, which in this case is just an x, x there, 1 and 5 don't have anything in common besides a 1. Alright, so what goes inside the brackets here? Well, x times what? Gives me x squared. Another x. X times what? Gives me negative 5x. Negative 5. Okay? So I have now that x times x minus 5 cannot equal 0. Okay? So these are two things multiplied together, and I know that they can't equal 0. So when two things are multiplying to give you 0 or not give you 0, then the first solution to this little thing here would be when this is 0. Because if this was 0, then 0 times whatever this piece is would still give you 0, right? So my first solution, my first non-permissible value, comes from when this thing here, which is just x, cannot equal 0. Well, this is actually already solved for us now. This is our first non-permissible value, x cannot equal 0. My second non-permissible value is going to come from here when this cannot equal 0. So x minus 5 cannot equal 0. Solve for x, so this is a minus 5. To get rid of that, I would add 5 to both sides of the equation. So that will give me, of course, x cannot equal a positive 5. So you notice how when I had a quadratic, just like how I had two solutions to a quadratic equation, I have two non-permissible values coming out of this. Alright, let's do two more. So this one here actually works kind of similar to the last one, but it's not quadratic. So what I've got here, 3x, of course, doesn't matter what's on top. Denominator, sorry. Well, I notice that this does have an x, but the 18 doesn't, so I don't have a common x. But I do have 6 in common for both of these, right? So what I can do in order to solve this right here is I can say, okay, I've got a common 6. Okay? So I could say 6 outside of something cannot equal 0. Alright, 6 times what gives me 6x? X. 6 times what gives me a positive 18? Well, a positive 3. Okay? So again, same idea. My first non-permissible will come from this being not 0. So 6 cannot equal 0. Well, if I look at this, it's true. It's a true statement. There's no variable here, is there? So there's nothing to solve for. So this actually doesn't really give me a non-permissible value. This, though, this bracket here will give me a non-permissible value because I can say that x plus 3 cannot equal 0. Of course, subtract 3 from both sides now, giving me x cannot equal negative 3. And that's my non-permissible value for that one. And I should mention, by the way, that if you take these values and plug them back in, you'll see what happens, right? Putting negative 3 in here, well, this is 3 times negative 3, so this gives you negative 9. That's fine. 6 times negative 3 gives you negative 18 right here. And negative 18 plus 18 gives you 0. So you end up with negative 9 over 0, which of course I can't evaluate. Okay? So that's why this is the non-permissible value. Okay? So you can always double check your answer there just to make sure that this works. Alright, last one. So we notice again, this is actually a quadratic again with a common factor of x. So I can just take my 2x squared minus x, set it not equal to 0, factor out my common factor of x. Okay? Well, x times what gives me 2x squared? Well, you can think of this as a 1. So 1 times what gives you 2? 2. X times what gives you x squared? X. Okay? And x times what gives you negative x? Well, negative 1. Cannot equal 0. So again, I've got two brackets here. The first one, set it not equal to 0. Gives me my first non-permissible value. Second one, set it not equal to 0. I need to do a little bit of work here, but not too bad. Get rid of the negative 1 first, so subtract 1. I can get rid of that by adding 1. So that, of course, will give me 2x cannot equal 1. Now to solve for x, I would have to get rid of the 2. To get rid of the 2, I'd divide by 2 on both sides, giving me x cannot equal 1/2. Okay?